Another shape that's available for your disposal in JavaFX is the arc, and the arc is basically a piece of an ellipse. As such, it's going to have a center x and a center y and a radius x and a radius y, just like an ellipse would. However, being a part of an ellipse, it's actually just a little piece of the outside of the circumference of the ellipse. It has a particular starting point and a particular ending point. The starting point is denoted by the start angle. That tells where on the outline you'll begin. And then there's the arc length, which tells you how far you will go along the ellipse before stopping. But that is actually measured as an angle as well, rather than an actual length as such. As it turns out, both the start angle and the arc length are measured in a way that's consistent with what you learned in your mathematics classes. That is that negative angles represent clockwise rotation and positive angles represent counterclockwise rotation. In all cases, you start on the place where a horizontal line drawn from the center towards the right-hand side intersects the ellipse, and that would be your starting point from where you measure angles. And you can see that in this diagram. So in diagram A, for example, if you start at that line that I just described and you come down negative 30 degrees, then that represents a clockwise rotation from that line to where the top arrow points to. And then the arc length is measured as negative 20 relative to that point. So in other words, the arc angle is measured from wherever the starting angle is, not back from the origin or the original place, not back from that horizontal line, but rather from where you wound up after applying the first angle. So in other words, the arc length goes from position negative 30 degrees to negative 50 degrees actually, because it's a 20-degree span that goes from negative 30 to negative 50. The two angles that you use to specify the arc, to define the arc, can be independently positive or negative. In this example in B, we use a negative angle to represent the starting point and a positive angle to represent the arc length. So you're actually coming back. In this case then, we say negative 50 for the starting angle, positive 20 for the arc length, and then what happens is you wind up getting a piece of arc that goes from the negative 50 degree position back to the negative 30 degree position. There are two constructors available for arcs. One produces an empty arc and the other has all the required parameters to fully describe the arc. This demo is rather important in the sense that there's a couple of things that were not covered in the slides that we're only going to cover in the demo, and that is that there's a number of different types of arcs that are available, and we're going to see those as we go through this demo. The three types are the round arc, the open arc, and the chord, and all of them will be demonstrated here. Again, this material is not covered in the slides themselves, so it's very important that you watch this video. So this stuff at the bottom, as we know, we don't need that in Eclipse. Let's get rid of that right off the bat. We have a bunch of imports up at the top that are necessary for the demo. We extend the application, we override this start method, all old stuff. And then down here we probably do the same stuff that we always do. We create a scene and we drop something into the scene, in this case a border pane with a group, and that will be something that we'll have to look at because that actually determines what we're going to see. And then we title the window show arc, drop the scene into the stage, and we show the stage. So that's all old stuff. So we need to look at this section that you see right here. Well, what you see happening inside of there is we actually define a total of 4 arcs. There's only 3 different types of arcs, so we're going to have 2 of the same type in 2 of the cases. But nevertheless, there are 4 different arc objects that we create. They're all of class arc, and we give them names arc 1, arc 2, arc 3, and arc 4. So let's take a look at how we make each of the arcs. Well, we start by saying equals new arc, and then we give the version of the constructor that has all the parameters in it to fully define the arc. So let's go through and think through these parameters that we see here. Well, the first 2 are, as you know from the constructor, are the x and y center of the ellipse that the arc is going to be based on. The next two are the x radius and y radius, and they're both 80 in this case, which means this effectively is a circle that we're making an arc on. And you can see that's true of all of them. So even though this is a general arc that can be made by an ellipse, in our demo here, every single arc that we make is based on a circle, because we have the same x radius as we do y radius. The final two parameters are going to indicate the start angle and the arc length angle respectively. Now notice what the author has done here with the start angle, and I guess I should be talking up here on the first arc. So the first arc we just see 30 as a start angle. Then on the next arc we see 30 plus 90, and then we see 30 plus 180, which is like 90 more yet, and then 90 more yet again would be 30 plus 270. So the author has intentionally and deliberately expressed this in his source code in a way to make it very clear that you're basically going around a circle 90 degrees at a time to 4 different positions, but every single position is starting at 30 degrees more than that particular quarter of a circle would be. Then the final argument in all cases is 35. And now you can see it's clear from that and what we're going to see in terms of output that this is a change in angle, not an absolute angle. So from where you are, you're going to go plus 35 degrees more to complete the arc. In other words, the arc length is 35 degrees in this case. Now all the angles you saw were positive. That means they're all going to be counterclockwise with respect to a horizontal line drawn from the center, located here in every case, 150, 100. And then going counterclockwise 30 degrees up to start the first, and then from there 90 degrees more, 90 degrees more, 90 degrees more to go around and make 4 arcs around a circle. So it turns out to be relatively easy to go through this source code because it has so much in common. Even though there's 4 separate arcs, they are very, very similar. Now let's look at the differences that we do have. Well, in the case of the first arc, we use a fill color of red right here, and I'm going to save this line for last. Let's not even talk about this. This is the last line in each section. We're going to come back and look at it later. The next one, we set the fill color for it for white, and we set the stroke for black. And again, we'll come back and talk about this mystery line later. The third arc, we set the fill color for white and the stroke color for black. And finally, the fourth and last arc, we set the fill color to green and the stroke color for black. So apart from the colors then, the only differences between the 4 arcs now are the type of arc. And there is a set type method that allows you to choose which type of arc you want. And in the case of arc number 1, we're selecting something called arctype.round. So this is a round arc. The next arc has an open arc. The next arc has a chord arc. And finally, the last arc also has a chord arc. So again, the 3 types were round, open, and chord. And we're going to show those all in just a moment. Finally, we're going to also produce labels for each of the arcs, giving the arc name, arc 1, arc 2, arc 3, arc 4, and the type of chord that it is, round, open, chord, and chord. And I don't suppose you need much help figuring out this part right here, because this is merely where we put the appropriate labels beside each arc in the appropriate, using the appropriate coordinates for each of the pieces of text. We also include the arcs themselves, so we're adding that all to a group there. And again, as you saw earlier, we can juggle the order of these things around. The order is completely immaterial because this is a group and they all have their own coordinates associated with them, so the positions they go are determined solely on the basis of their coordinates. Now, I haven't actually explained what the difference is between an open arc and a chord arc and a round arc, but I think we'll show the demo first so we have some context in which to discuss each of those differences. So I'm going to go ahead now and run the code, and there we have it. And perhaps Well, okay, it's not going to make it bigger and easier to read when I do that. It keeps it centered at least, but in any case, let's go through and have a look at the different types of arcs that you see here. So an open arc, arc 2 for example right here, just as the name would imply, is an open arc. We just have a line right off the ellipse, starting point, ending point, nothing else. The chord type of arc, on the other hand, gives a straight line that joins the two ends of what otherwise would be an open arc. And then this arc is the same. It's also a chord arc, and here's the straight line portion up here and the elliptical portion down here, and the only thing is we filled it with green as opposed to this one, which we filled with white. Now over here, this is the only last type of arc we haven't talked about yet, is the round arc, and it looks basically like a piece of pie. Essentially, you get a straight line from each end of the arc to the center of the ellipse. Now when you look at this, it's very clear that our ellipse is actually a circle, as I mentioned earlier. And then of course this particular round arc was filled with red. So there you have it, a round arc, two different chord arcs down here, and an open arc back here.